After the successful Chandrayaan mission, ISRO came into limelight. In fact, it has been doing tremendous good work for many decades. And as Indians, we are all proud of ISRO and the achievements that it has in its name. Today, after having almost conquered the moon, we have yet embarked on a new mission, that is the Aditya mission, where we are going to study the sun also. And somebody from ISRO comes and tells us about how the ISRO functions and what this mission is all about. I think we have amongst us today, thanks to our PDG, BM Shivraj, we have an eminent scientist from ISRO, Nigar Shaji. Should I ask the AV team to put on the introduction? And may I now request BM to escort Nigar Shaji on the stage. Friends, a big round of applause for Nigar Shaji.
Nigar Shaji is an Indian aerospace engineer working at Indian Space Research Organization, ISRO, India's national space agency. Shaji joined ISRO in 1987 and has risen through the ranks and is now the program director for all lower orbit and planetary missions. She was ISRO's project director for Aditya L1 mission. Aditya L1 is the first space-based Indian mission to study the sun. The spacecraft is placed in a halo orbit around the Lagrange point 1 called L1 of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. A satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the sun without any eclipses. Shaji and her team started working on the Aditya L1 project in 2016. Though the COVID pandemic stalled their work around 2020, when ISRO activities came to a near halt, the project work never stopped. She and her team continued to work on the solar observatory. Shaji and her team kept a hawk's eye on the spacecraft throughout its journey towards the L1 point from the Earth after several maneuvers. Due to their hard work, Aditya L1 has finally reached its destination, the halo orbit, from where the spacecraft will observe the sun without any hindrance. The 59-year-old Shaji, who's playing a key role in several ISRO missions, has now become a role model for many women who want to pursue a career in space science. Nigar Shaji.
Yeah. Very good morning to you all. And first of all, my thanks to Rotary District 3142 for giving me an opportunity to share the stage with the great achievers, especially Madam Indu Prabha. So, and also my thanks, my compliments and congratulations to all the Rotarians here for their committed service to the humanity, and also for the thank you for the opportunity for me to share with you the incredible journey of Indian space program. Yeah, it all started by the great visionary, Dr. Vikram Sarabhai, okay, who had a great vision that the advanced technologies in space to be used for the betterment of the country and lift the standard of living of every common man of the country. So at that point of time during 60s, there were eyebrows raised that is a space program is required for a country which is developing and poor. But this man was very firm that this is very much required for the holistic development of the country, and we should be second to none in advanced technologies. And at that point of time, the government also supported, and there forms the Indian space program in the 1960s. Yeah, these are all the iconic photographs which shows the humble beginnings of the Indian space program and also with a shoestring budget. And you can see in the photograph a man carrying a rocket part in the bicycle. So initially the program started with the small rockets with help from Russian space agency. And it was a small rocket which can only lift up to 100, 200 kilometer, and it can carry only a few kgs of the payload for some studies in the atmospheric science. And now today, we have the biggest vehicle which can carry up to 4 tons of a spacecraft to a geostationary sub-GTO orbit, and it can carry 10 tons to the lower orbit. And the other side, see, one side we have both developed together to have an indigenous rocket program as well as the spacecraft program. Spacecraft is the only one which stays in the space for years together, and it serves the humanity for various applications. And there you see one of the spacecraft, the initial days, it was taken in a bullock cart. And that it was an innovative idea of our forefathers that this can be used as a test facility for if the same test has to be done at that point of time, it calls for a huge cost to construct this test facility. So it was very innovative. They used the bullock cart as the test facility to do the test, and this spacecraft was launched. Because the initial days we never had the rocket capability, so we used to take the launches from the other countries, both from Russia and US. So that's how we had the humble beginnings in the church building. It was started all in one small church building at Trivandrum. The show, Trivandrum shows, and later it becomes a big organization today. And I'm really proud and fortunate to be part of this finest organization of the country. And one more thing I like to say here, unlike other organization, I don't know about that, but it's an organization where there is no gender diversity and there is no glass ceiling to break. And everyone will be given an opportunity to test, to prove yourself if you have a metal talent and capability. So that's how I got a chance to lead the country's prestigious Aditya L1 mission. Some 8 years ago, I got the chance and I could prove it successfully, and that earns me a lot of respect in the country. Yeah, we started initially because as the motive with which the program started, so we had started our program mainly for the applications initially. So the application should be useful to the humanity. So first we started parallelly with the Earth observation as well as the communication spacecraft. So Earth observation today, if you see, we have started, and we have a lot of array of spacecrafts in various themes. See, we have today the land and water resource management for disaster management, water resource, land, forest fire, so many applications we have the themes. And one is the land and water resource management. We have a lot of spacecrafts today, which we improved from once the spatial resolution was 70 meter. That means that 70 meter object at ground only can be seen. Today, we have a capability of sub-meter, that is 25 centimeter objects we can see from the space. So another application is for strategic and cartography and large-scale mapping. We have a separate fleet of spacecrafts for those applications, and also we enter into ocean studies or also climatic studies. That is a need of the hour of today for the climatic studies. So we have the 3 different themes of Earth observation satellites today. And next come the communication satellites. Communication satellites, we have all the varieties of transponders and whatever, most of our banking, stock market, everybody hires, and lot of demand for our transponders, and everybody hires our transponders, and we earn a lot of economy for the country too by our transponders. So communication also we are equally doing good. That is also the another biggest application which is very much required for the common man. Then we also have weather satellites. Whatever the weather reports, what you get every day, they use a lot of our weather spacecraft. We have specific weather satellites made for weather department, IMD, Indian Meteorological Departments, and they are doing that service to the weather satellites. And having completed to some extent what the goal, what the Indian space program was started, like applications, later we faced a problem that whatever the GPS what you have today, that you will be using it for all your location, navigation, everything. But this same GPS for our strategic applications, we will not get that required accuracy. So we decided, having achieved a sizable success in both the communication as well as the Earth observation, we ended into navigation, and today we have our own constellation of navigation spacecrafts, and our strategic people are using it. And also there's going to be a rule made, all your mobiles will be coming henceforth with the Navic receivers, so that Indian navigation system also can be used worldwide if you want, because it's a regional navigation system. So the countries in and around India can use it. So we entered into the navigation system. So next, the interesting part, the very challenging part is, having achieved so much in the application arena, we ventured ourselves, though our initial intention was not to venture into such space science and a big exploration. Our main aim is to serve the common man's needs. But once we have attained self-sufficiency in the common man requirements, we embarked ourselves to space science and exploration. So we started it's altogether a different ball game. Here the space science and exploration little more challenging than the application. Here we need to leave the Earth and travel, and also reach the other planets or the moons, and then we have to landing. That's all. It's quite challenging and tough, and we are very, very happy that Chandrayaan 3 could made a lot of ripple, because we were told you could see that more than, because in India, as we were discussing previously, the cricket match was the widely watched one. But we saw that Chandrayaan 3 on our landing day, the people who watched the Chandrayaan 3 landing was much bigger than the cricket match watchers. So we really proud of it, and so that we are also happy that we could play a much bigger role in contributing to the national pride, and also inculcate some scientific temperament in the minds of the young generation. So that way ISRO has done its job not only in the applications area, and also to country's pride and the scientific temperament inculcation. So we started our journey in the space science and exploration with Chandrayaan 1, which is an orbiter around the moon. Then we had an astrosat, which is a totally science mission. It's a low orbit mission, but it is something like a Hubble telescope. You might have heard NASA's Hubble. It is something like a Hubble, but its capabilities are a little lesser than the Hubble. But it gave a lot of new papers which unraveled so many secrets of the universe, the observations. And next we had that Mars mission. We also, in our first attempt, we could land on we could orbit around the Mars. Then came the Chandrayaan 2. Chandrayaan 2 orbiter. So there we had a failure, and that's always the space is very unpardoning. Any small mistake, which it's not be pardoned. So how well you anticipate the failures, and how well you anticipate the failure cases, and how well you test it, there lies the success of your mission. So maybe we might have missed some of the failure conditions. So we ended up in a failure, but we got up from Chandrayaan to failure, and all the failures were corrected in Chandrayaan 3, and we could land. Very historic landing on the south pole of the moon, the first in the world to do so. So that's the great achievement. And then comes the Aditya L1 mission. I'm very honored to be the project director of Aditya L1, which is the project started 8 years ago, and we had actually one of its kind best instruments, whatever Aditya L1 has. It's mainly for the space weather studies, and also unravel the secrets of the sun. And So it was a huge success, and we could insert into the halo orbit, and the instruments are working fine, and in the future we may get a lot of science out of it. And also we had recently one more science mission, the polarimeter, that X-ray polarimeter, which could observe the black holes and the supernova in the space. So that is also a first of its kind. Next to NASA, we only have that such a mission for the science. So this is how our journey is going on, and we are because of these successes, we have got more responsibility and more confidence to travel further into the space science and exploration. We have a lot of plans to go and have the sample return mission from moon, and also finally have the man on moon, also to land on Mars, and also to study Venus, and also to study the universe. So we have a lot of ambitious plans. It's all because of your support and whatever the confidence we got from the successes of these missions. So if you see, I have just listed in what are all the 4 variants we have been working with. Just I have explained. One is the Earth observation category, and the next is the satellite communication category. Then navigation and space science satellite. These are all the 4 categories we are presently working on, and most of the nations are working on these 4 categories. And I'm proud that we are going ahead well with all your support. And next, having achieved all these 4 categories, we are now embarking into a Gaganyaan mission, that is taking man to space. So there's initial our test, a separate crew recovery procedure and all has been tested, and it is all successful, and hope another 3-4 years we'll be able to take the astronauts to space. And the astronaut training also is completed. The astronauts will be taken to space. And following that, we have an ambitious plan of having our own space station, like what you might have heard as ISS, International Space Station. Similar to that, we have a great goal of setting up India's Bharat Antariksh Station in space. Yeah, on the launch vehicle side, as I have explained, starting from the small rockets, we moved on to the payload capacity slowly increased, and we have a PSLV which carried Aditya L1, which can carry only 1,400 kg of the spacecraft, and the LVM-3, that is the highest one, we have 14. This also, we are progressing very well, and we have plans up to have a vehicle which can carry 10 tons. So that's how we are progressing. Yeah, all these programs, how ISRO manages. ISRO manages with 5 verticals. We have almost 20 centers all over the country, and each center have a specific task to do, and we have 5 verticals. One is the space transportation. This is the launch vehicle side, where a lead center will be there, and there will be supporting centers. Similarly, for space application, space application does all the communication transponders or the cameras for viewing the Earth. All those things will be done by one lead center supported by other centers. Similarly, space infrastructure, where I am part of it. So space infrastructure is have the responsibility to build the spacecrafts, and we are all supported by many sister centers who does sensors. One center will be doing sensor, one sensor will be doing the propulsion. So and we have the human space program. There is a separate vertical. So because human rating, we need to have a much better rating. We should have very good redundancy, because we are taking the human to space, and we have to safely bring him back. And next is to support all this, we have a vertical capacity building, that is the launch base and all the test facilities, everything. So being a project director, each mission, the project director has to interface with all these 5 verticals and get the mission done. So that's how here the people management and decision making become very, very important for a project director to have his mission successful. So we operate on these 5 verticals of management. So, having served 5 decades of Indian spokes, we had a lot of accomplishments. We have 123 spacecraft satellite missions. We had 95 launch vehicles being launched, and 430. We have also serving our launch vehicles will be serving, giving commercial support to launch the other nations' spacecrafts also. And we have till now 432 satellites from the 34 countries also we have launched, and thereby we are providing and our space economy towards country's economy too. Now, yesteryears it was a luxury, space program was a luxury, today it is a necessity. And then it also, space economy is forming a part of the global economy, and today we are only contributing 2% of the global space economy. So our idea is to go further and make it 10% in a span of a decade. So that is the goal of Indian space program. And we also have a lot of international cooperation, because we have, it's about to be launched, we have a NSR joint mission for the climatic studies with NASA, and also we have France cooperation for one another project, Trishna. Then we also have a JAXA, Japan Space Agency collaborative program. And also we have ESA. So almost all the countries, we have a lot of international cooperation, and with our Chandrayaan-3 landing and our reputation in the global space agencies have improved a lot, and they are really coming forward to have a good cooperation with us. That's what the Chandrayaan-3 has created in all over the world, what we get a lot of respect from the other space agencies. Yeah, that's, thank you for the attention. And it's really honor to be here to say about our programs. Thank you.
Friends, yet again another wonderful speaker to throw light on the subject of which we always keep on reading in newspapers or watching all those things happening on the small, that is the idiot box, the TV channels. May I now request our dignitaries to come on the dais. I request PDG BM Shivraj also. And friends, ISRO is an extended family of all Indians, but Nigar Shaji is actually a family from the Rotary Club only. Her brother is PDG Sheikh Salim, who is very much here. He is from District 3212, Kanyakumari. So she is in the Rotary family too, and we are really very proud of you, madam, that you are part of the family. May I now request the dignitaries, DG Milind Kulkarni and Dr. K. Ravi Appaji to felicitate Nigar Shaji. A big round of applause for her and for her achievements. We are also thankful to PDG, BM Shivraj and Manumani to have brought such a wonderful speaker to this conference.